Every breakthrough in artificial intelligence begins the same way, with a bold idea, a new way of seeing patterns, a smarter way of predicting outcomes, a system that promises to solve problems we once thought were unsolvable. But between imagination and impact lies something far less glamorous: hardware, the physical machines that must carry the weight of every brilliant concept. And sometimes it isn't the idea that fails, it's the machine that can't keep up. If you're fascinated by the hidden forces shaping the future of technology, stay with me. When we think about AI, we picture algorithms, data, and digital magic, but none of it exists without physical infrastructure. Servers in massive data centers, chips etched with microscopic precision, cooling systems humming in the background. AI may feel abstract, but it runs on very real, very limited hardware. Every calculation requires electricity. Every prediction requires memory. Intelligence in the artificial world is constrained by silicon and metal. It's easy to forget this because software moves quickly. It updates overnight. It evolves in weeks. Hardware, by contrast, moves slowly. It requires factories, supply chains, and years of engineering. When AI ideas grow faster than hardware improves, tension builds, and tension creates limits. Some AI concepts look extraordinary on paper. Larger models, deeper learning systems, real-time intelligence embedded everywhere. But ambition demands computation, and computation demands power. If the hardware cannot process the workload efficiently, the idea becomes impractical. Imagine designing a sports car engine without considering the strength of the road beneath it. It may be powerful, even revolutionary, but if the infrastructure can't support the speed, the car cannot perform. In the same way, AI breakthroughs sometimes stall, not because they lack brilliance, but because current hardware cannot support them at scale. There is another limit that hardware quietly imposes: cost. Training advanced AI systems requires enormous amounts of processing power. That means expensive chips, vast electricity consumption, and sophisticated cooling systems. For large companies, this may be manageable. For startups with visionary ideas, it can be devastating. A brilliant AI model that costs millions of dollars to train and operate is not accessible innovation. It becomes a financial barrier. Many promising AI ideas never reach users because the hardware required to sustain them is too expensive or too scarce. In this way, hardware shapes not only what is possible, but who gets to participate. AI is not just a digital challenge, it's a physical one. Every computation generates heat. Every server farm consumes energy. As AI systems grow larger, their environmental footprint expands. Hardware must manage this heat, distribute this power, and prevent failure. There is a quiet irony here. The smarter our machines become, the more they depend on basic physical constraints: electricity, cooling, space. These are not abstract limitations. They are realities that define the boundaries of innovation. An AI system that overheats or drains unsustainable amounts of energy cannot survive, no matter how intelligent it appears. In recent years, demand for specialized AI hardware has surged. Powerful chips are not unlimited. They require rare materials, complex manufacturing processes, and global coordination. When supply chains tighten, progress slows. A startup may design a remarkable AI solution only to discover it cannot access the hardware required to deploy it. Larger companies secure the supply. Smaller innovators wait. In this way, hardware scarcity shapes competition itself. It determines who moves forward and who stands still. Yet constraints are not only obstacles, they are teachers. Some of the most impactful AI systems were built not by demanding infinite computation, but by working intelligently within hardware limits. Efficiency becomes a creative force. Engineers learn to design smarter, leaner systems that accomplish more with less. The future of AI will not belong solely to the largest models or the most powerful machines. It will belong to those who understand that hardware is not an afterthought. It is part of the idea itself. Great A I is not just about what the algorithm can imagine. It is about what the hardware can sustain. Artificial intelligence may feel limitless, but it lives inside very real boundaries. Every great AI idea must pass through the filter of physical reality. Silicon, energy, heat, cost. These limits do not kill innovation, but ignoring them can. If this video helped you see the hidden side of AI progress, take a moment to like the video. It helps more curious minds discover thoughtful conversations like this. And if you enjoy cinematic explorations of technology, innovation, and the forces shaping our future, subscribe to the channel. There's much more beneath the surface. Because in the end, intelligence is not just about ideas. It's about the foundations that carry them.